Okay, today's lesson is 6.7 probability and odds. Here are the first 4 vocabulary words in the lesson. I've crossed off what I can for you. Right, everything else needs to be written behind your vocab word for the definition, so you are able to study it appropriately for the matching on the test coming up next week. These are the last 4 of your vocab for lesson 6.7. Theoretical probability, experimental probability, odds in favor, and odds against. Alright, today we are learning 6.7, like I stated, probability and odds. So you have a worksheet today. The whole front side of the worksheet is dealing with your probabilities. The back side of your worksheet, you're figuring out all the odds. Alright, the 2 main things that we're learning today. Now, the first part here they talk about is the probability of an event when all outcomes are equally likely. So that means the probability. So a probability that I draw one of your names out of a hat. How many in this classroom? What do we have? 23 in this group? So the probability of me drawing Sterling's name out of a hat is what out of 23? The probability that I draw his name is 1, because he has the name in there once, unless he cheated and put it in there 2 or 3 times, right? No, he wouldn't do that. Okay, so the probability of that happening is 1 out of 23. What's the probability that I draw your name instead of his? Same thing. The probability is still 1 out of 23. You always put the total on the bottom. The total possible outcomes is 23 names. I said one of yours names, so it would be 1 to 23. You can also remember write that as 1 to 23 or 1 to 23. What happens if I have a probability and it ends up being 4? Let me clear this. What if the probability of getting a brown dog out of a litter of 14? Big batch of puppies. 14 puppies. Huge batch. What's the probability of getting a brown one? If 4 of them are brown, 10 of them are black.
4 out of 14.
Exactly, I would be 4 out of 14. However, am I done?
No.
Why not?
Simplify.
Absolutely. You still have to simplify your ratio. What does that simplify down to?
7.
Excellent. 2 to 7. So for every 7 puppies, 2 of them are brown. The probability of getting a brown one, 2 out of every 7. So for that mother to have a brown puppy again in the next batch, the probability is that for every 7 puppies she has, how many of them will be brown? 2. How many of them will be black?
5.
What's the probability it's a black one? If the rest of them were black? 5. 5 out of 7, that is what we were talking about. Okay, that is just a little fun. Now let's go to the problems. Like I said, this is going to be the front side of the worksheet. Finding probability. Suppose you roll a number cube. What's a number cube?
Dice.
Yeah. If you have 2 of them, they're dice. If you have 1, they're called a die. On your worksheets, most of the time they're referred to as a number cube. So suppose you roll a number cube. What is the probability that you roll an odd number? All right, I'm seeing hands already. That's good. First of all, let's fill this in. Rolls of what are odd? What numbers on a number cube are odd? Blurt them.
1,
3,
5.
and 5. So there are 3 favorable outcomes. That was one of your vocab. 3 of the outcomes are favorable. Well, how many total outcomes are there?
6.
So there are 6 possible total outcomes. 3 of them out of the 6 are odd. So what is our probability? That equals 1 to 2. So what does that mean? Say that in words. What does that mean, 1 to 2? Half? What do you mean?
Half of 1.
Half the batch is able to get.
Two rolls, you get 1 on.
Right, there we go. For every 2 rolls, one of them should be odd, right? That's what they're saying. So I want to skip ahead right here where it says experimental probability. Let's put that to a test. An experimental probability. We just learned that the probability of getting an odd is 1 to every 2 rolls, right? Let's bring up our handy dandy little dice roller here. And let's keep track and see what happens. We'll roll it. What is that?
1.
Which is?
Odd.
Even. What did that work out to be?
1.
1 out of the 2 rolls, right? Hey, sweet. That was a good example. That one worked. Let's do it again. Odd. Even. Wow. Do it again.
Odd.
That was 2 out of
2.
2. Do it again.
Even.
So what do I put? Even and an odd was 1 out of 2. Do it again. Even. Wow. And this is not fixed.
Right here.
It's random.
Even.
All right. One more.
Even.
Oh my.
How many do we have here? 2, 4, 6, 8, 10, 12, 14, 16. Let's do it 2 more times so we get to 20.
Even. This is a good example.
Odd. Even.
Ooh, 2 odds. So what do I put here now? 2 over 2. So this one worked out a lot of the times to be 1 to 2, didn't it? But let's see when you add them all up now. Out of 20, if I were to add all these, how many out of 20 were odd if you add up your whole data? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 20. Is that pretty close to half?
Yeah.
All right. So the point I'm trying to make here is if the more data that you have, the more trials you have in your experiment, the more what? Accurate or less accurate your data will be?
More accurate.
Yes, the more accurate your data would be. Okay, let's clear this. What was this called that we just did?
Experimental data.
That was an experimental. An experimental what?
Probability.
Probability. Excellent. All right, now let's go back. Right there. Let's practice our probability. Suppose you roll a number cube. What is the probability that you roll a number less than 5? So probability. How many total outcomes are there on a number cube?
6.
What if I had a spinner? Because on your worksheet, there's some with a spinner. And it has a little arrow on it. Well, how many outcomes do I have on a spinner like that?
8.
I would have 8, so that would be out of 8 on your worksheet if we're doing probabilities. But back to the number cube, how many numbers are less than 5?
4.
4 of them are. 4 to 6, which equals
3.
2 to 3. So for every 3 numbers, 2 of them are odd. What would it be on this spinner thingamabob I just drew over here? How many numbers are less than 5?
4.
Still 4, isn't it? But now it's not 6 total outcomes. We now have 8 on this one. And that would simplify down to 1/2. So for every 2, one of them is odd. Suppose you roll a number cube. What is the probability that you roll a number that is a multiple of 3? Who wants to give me a guess?
2.
2. Where do you want me to put a 2?
On top.
On the top? Would you agree?
Yeah.
What are the numbers that are a multiple of 3 on a number cube?
3 and 6.
3 and 6. So the probability of getting a 3 or a 6 is 2 out of 6, and that equals
1/3.
1 to 3. Let's do that one on the spinner over here. The probability of a multiple of 3 on that spinner. How many multiples of 3s do we have here? 1. Still 2, isn't it? So 2 over 8, which equals
1/4.
1 over 4. Questions? You guys are just doing great. Okay, let's continue on. Oops. Now we go to that example 2 when we were talking about experimental probability. What experiment are they running here?
Planting of seeds.
Planting of seeds. This person planted how many seeds?
32.
32 of a certain flower. How many sprouted?
18.
18 of them sprouted. Find the experimental probability again that the next flower seed planted will sprout. What over what?
32 over 8.
32.
Say it again a little louder.
18 over 32.
Good. 18 over 32. Simplify that and you get, what do you get? Divide by, what do you want to divide by to simplify this?
18. 9. 18. Divided by 18.
11, 6.
Well, if you're not sure, they're both what?
6.
Even.
They're both even, so let's try dividing by 2 and go from there. 18 divided by 2 is?
9.
What's 32 divided by 2?
16.
Can I simplify 9 over 16 anymore?
No.
Yes or no?
No.
No, there is not a number that goes into both 9 and 16. So 9 over 16 is in our simplest form. So what that tells us is for every 16 seeds, how many sprout?
9.
9 of them would sprout. Well, I want to know a percentage. What percent is that? To the nearest whole number.
56.
I'm hearing 56. How did you get it?
9 divided by 16.
Ooh, you guys are on it. Yes. So 9 divided by 16, you end up getting 0.5625,
25.
blah, blah, blah. Well, round it to the nearest whole number, taking it times what?
10.
No, higher.
100.
100, taking it times 100 or moving your decimal to the right twice, you end up getting 56.2, which rounds to 56%. Now, if you're a farmer, are you excited about the seed you bought?
Not.
Yes or no?
Not.
No, you'd be one broke farmer, right? You walked out to the field and only 56% of your seeds have sprouted? Wah, 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 right? You do not want to buy that seed again. That is not a very good outcome. You want to have more of your seeds growing than just 56%. All right, now we'd be on the back side of our worksheet. Odds, finding the odds. Suppose you randomly choose a number between 1 and 16. So how many numbers do we have total?
16.
Duh, 16, right? We have a total of 16. Now if we were doing probability, that would be on the bottom, wouldn't it? Now we're doing odds though. That is not our denominator anymore. That is what our numerator and our denominator better add up to, because we have to do a little subtracting. Let's do letter A first. What are the odds in favor of choosing a prime number? First of all, let's list the prime numbers between 1 and 16. List the first one.
1.
Is 1 a prime number?
No. Yes.
No.
Yeah.
2.
No, 1 is not considered a prime number, so on to the next one. What would it be?
2.
2,
3.
3,
5, 7,
11.
11,
9,
13,
11.
13, 17.
Okay, but it's between 1 and 16, so
Let's see.
how many are prime between 1 and 16?
6.
There are 6, what kind of outcomes? 6,
Prime.
6
Favorable.
favorable outcomes. So we know 6 goes on the top. 6 favorable outcomes. How many unfavorable?
10.
How many are not prime? 10. All right? Because there's a total of 16. 16 minus the 6 that are prime, that leaves us with 10. Now notice when you do odds, your numerator and your denominator, when added up, 6 and 10 equals 16. These two added together before you simplify, right? Before you simplify, you add up to your total of 16 over here. So now we simplify and we get 3 to 5. Our odds are 3 to 5 that you choose a prime number. What are numbers that aren't prime? All the other ones are called what? Yes, good job. Composite, good memory. Now, we don't really get into odds against. It's not in our standards, I don't believe, but it's so easy I just have to touch on it because it is just so simple, it just hurts. If this is odds in favor, 3 to 5, what are odds against it?
2.
5 to 3.
Exactly, you just flip it around. So if odds in favor are 3 to 5, odds against it are just 5 to 3. Just flip it around, that's all you have to do. Questions on the odds? Your homework is your worksheet. All right. Now, how many letters in the alphabet?
26.
26. On your worksheet, it asks you about vowels. What are the vowels?
A, E, I, O, U,
What about Y?
sometimes Y.
No, we don't count the Y.
Aw.
Today's not a sometimes day. A, E, I, O, U. What are those? Those are vowels. What are those other letters called?
Consonants.
Consonants. That is in your worksheet. Question. All right, you may start.